Hello, today we are going to review Unit 3, Parallel and Perpendicular Lines for Geometry. Make sure you have your calculator out. Make sure you have your paper to do your work on as well. First question. We're going to write an equation for a line that passes through point 2, 1 and is parallel with the equation y equals 2x plus 6. Okay, a couple things that are going on here. First, if we're going to write an equation of a line, we need to make sure we have a slope and we have a point. So right here we have a point. It says through this point. This equation will help us find the slope of that line we need to use. Because if we have a point and we have a slope, we can use point-slope form to write the equation of the line. So now, with that, how am I going to find the slope of my new line? Well, first of all, as I said, this equation here will help us find the slope. In this equation, we know that the slope is 2. It's right here in my equation. We know that we are looking for the line that is parallel. So our parallel slope, sorry, the pen's not writing, is the same as the slope of the other line. So my parallel slope is also 2. Then I have my point that I'm going to use, 2, 1. Now I can use point-slope form and write the equation of the line that passes through that point and is parallel to this other equation. So I say y minus y1 is slope, x minus x1, that's my point-slope form. I plug into my point-slope form using my slope and my point. This equation of the line that I found is the one that is parallel. I can tell it's parallel because my slopes are the same. And it'll go through this point here if I actually graphed it on a coordinate grid. Okay, given the graph, give the exact distance between the two parallel lines. Well, first of all, before I can find the exact distance between the two parallel lines, we know that one, distance has to be a perpendicular distance to be exact. So looking here at my graph, I need to know if, first of all, this is perpendicular, and if it is, then I can go ahead and find the distance between the 2 points. So first, how am I going to know if it's perpendicular? Well, the slopes. If I find the slope of the one line and I find the slope of the second line, oops, line 1, sorry. Then, if they're perpendicular, then I know this is the shortest distance between the parallel lines, and then I know that that is what I need to find the distance of. So, first, let me get this point. It's at 2, 1. This point here is at 0, 2. So, they didn't give you the other point to know that it was perpendicular. So let's find another point that we can see if they're perpendicular. So I'm going to use this point here, 1, negative 1, first to make sure that these are perpendicular. So my first line, I'm going to make the line that's perpendicular. So here, I'll take the change of my x, change of my y, change of my y over my change of my x. I'm going to take my second line here, so it's the change of my y over the change of my x. These two right here are the negative reciprocal, so I know the line is perpendicular. Because if my slopes are the negative reciprocal, then I know it's perpendicular. So now I know it's perpendicular, so now I know that I can just do the distance between these 2 points. So now, my distance formula tells me that the distance, same from Unit 1, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So now I'm finding the distance between these 2 points. So the distance between my x's squared, the difference between my y's squared, sorry, I was doing the math in my head. It's 4 plus 1. Sorry. So my distance is the square root of 5, which if I take out my calculator, it says give the exact distance. So I don't need to take out my calculator. Sorry. It asks for exact distance. It wants the square root answer. Sorry, that's a 1. Sorry about that. It wants the square root answer. So my distance is the square root of 5 between my 2 parallel lines. So just to recap, by the definition of distance, it says it has to be the point that's perpendicular to the line is the shortest distance. So I had to make sure these lines were perpendicular. To do that, they had to have a perpendicular slope, which is a negative reciprocal. Then I can take the 2 points, use my distance formula, and then it asks for exact distance, so therefore I left my square root. Okay, now I'm going to write an equation of a line with a slope-intercept of -5/2 and a y-intercept of 6. Well, first of all, slope-intercept, an equation of a line. Slope-intercept form says y equals mx plus b, where m is my slope and b is my y-intercept. So based on our directions here, it says I have a slope of -5/2. It says I have a y-intercept of 6, that's positive. There's the equation of the line with a slope of -5/2 and a y-intercept of 6. I just put it back into my slope-intercept form. All right, it says given the picture, name the transversal that forms the 2 given angles and identify the special angle pair. First of all, the special angle pairs, that would be the corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles. So when I'm looking at angle 8 and angle 16, okay, it says first name the transversal in the picture. So this is my transversal. How do I know? Because they're both around this line here. So this is my transversal. So O is the transversal. It's lowercase. So line O. If you want to put the word line, that's fine. Line O is the transversal. Remember, it is a line, so it is lowercase. Now they're both on the inside, so they're consecutive interior angles. Okay, for the second one, it says 9 and 2. So I need to find 9 and 2. So there's 2 and there's 9. They're hovering around this line here, so this line is the transversal. So line N is the transversal. And then they're sitting on the outside and they alternate, so it is the alternate exterior angles. Because they alternate on the exterior of the parallel lines, or of the lines. They're not parallel here, sorry, of the lines. Okay, given the picture, given this picture, name a line that's parallel to line DH. Sorry, that just happens with typing. So I want a line that is parallel to line DH. So DH is right here. So who's parallel? Well, it has to sit on the same plane to be parallel. So CG is, AE is also parallel. Either one of those you would name a line, but both of those are parallel. And actually, BF if we had that imaginary plane in the center, BF is actually also parallel. If you're only looking at faces, it would be CG and AE. If you're making the imaginary one, then it's BF. I prefer us not to look at the imaginary ones and just look at the ones that are given, but that can happen, technically not wrong. Name a line skew to AB. Well, here's AB here, so if it's skew, it does not sit in the same plane, and it does not, it is not parallel, and it does not sit in the same plane. So here, I could have DH. I could also, in this case, to this one here, I could have CG. He'd be parallel. He would cross. Down here, EH. Down here, FG. I think that's more than enough right at the moment. I think that works. Remember, skew, not coplanar, not crossing. Parallel is coplanar, not crossing. That's the difference between the two lines. So that's why these have to sit in the same plane. Okay, given the picture, find the missing angles. Alrighty, so let's get started here. So first of all, what do I know? I know that, excuse me, this line is parallel to this line. How do I know that? Remember that the little arrow on the line, because there's one arrow on each line, these two lines are parallel to each other. Because they're parallel, that means that some things are going to happen. So, because they're parallel, the first thing I can look for is alternate exterior, alternate interior, corresponding, or consecutive interior. Okay, all of that happens. Because they're parallel, this line right here is 124. That means this whole piece is 124, so I really can't go there yet. Okay, it's going to be, this whole angle is going to match this whole angle. I don't know this piece, so I really can't use that right now. So what else do I know? I know that if he's 124, I know that this matching side, y minus 8, is going to be 180. How do I know that? Because it's going to make a straight line. It has nothing to do with one of my reasons things are parallel, but this whole angle across here makes a straight line, so that I know 124 plus y minus 8 is going to give me a supplementary angle or a straight line. So I can solve for y. So with that, let's see what we got here. 124 minus 8. Oops, that was not 124, sorry. So 116 plus y equals 180. Subtract my 116 from both sides. So y is 64. That is not degrees. I'm finding, that is not degrees. That is just y. It says to find the missing angles. So that angle, y minus 8, would be then 64 minus 8, 56 degrees. So this angle right here is 56 degrees. If I'm finding the measure, it's a degree. If I'm finding the y, it's not. Okay, so if he's 56 degrees, then I know that now they're parallel. This guy right here must be 56 degrees because he's alternate interior, which also means that these two added together should be 180. And it is. 56 and 124 is 180 because they're consecutive interior, so that's good. All right, so now I know that if he's 56, I'm going to leave him there for a minute. I know that these guys are parallel, so if I look at this guy being a transversal, he is 60 and he is 60. Why? Because they are corresponding angles. So now if I can find the missing piece right here, then I've got a straight line. I know I've got 180 degrees. And sure enough, I have a vertical angle right across from it. So now I know that 60 plus the 56 plus the 2x is going to be 180 degrees. So I know that x is 32, but that's not what it asks. It asks for the missing angle. So I know that this angle then would have to be 2 times the 32 degrees, which then is 64 degrees. 64 degrees. So just to kind of cap, we're trying to find, it just says the missing angles. I'm not sure which angles they want. If we find this angle and this angle for x and y, that y minus 8 degrees, that angle is 56 degrees, and the angle that says 2x degrees is 64 degrees. It's kind of a weird question. Sorry, I should have numbered it. The point is, if you're finding the missing angle, it's a measurement. If you're finding the x or the y, which is typically how they have it done, that would be my x value, that would be my y value. All right, I want to find the value of x so that L is parallel to M. If I'm proving things are parallel, that means they're not parallel right now. That is my converses. If I want L to be parallel to M, that's going to be my corresponding angles converse postulate, my alternate interior angles postulate, alternate interior angles converse theorem, my exterior angles converse theorem, and my consecutive interior angles converse theorem. It's all my converses. It's the 4 of them. So when I look right here, if these two angles are congruent, because they are consecutive interior angles, then my lines would be parallel. That's what the converse says. So 110 equals 6x plus 2, then L will be parallel to M, if I find the measurement that makes that true. So x is 18. This value of x makes both of these 110 degree angles. So by the corresponding angles converse postulate, they are parallel. L is parallel to M. The converses make them parallel. The converses prove the parallelism. Okay, number 8. Find the slope for 6, -3 and 4, -2. All right, back to our old friend, trusty friend from last year. To find the slope of 2 points, we must use the formula for slope of 2 points. So slope equals y2 minus y1, x2 minus x1, where first ordered pair, first x, first y, second ordered pair, second x, second y. So now I just plug in y2 minus y1 divided by x2 minus x1. So -1/2 is my slope. Now I just like to have my negative sit in the numerator. It can actually sit in the numerator, the denominator, or outside of the problem. Okay, now I want to find the slope of a line parallel and perpendicular to a line passing through these points. So the first thing I'm going to have to do is find the slope of the 2 points. So again, y2 minus y1, x2 minus x1. So I have -3/2. So the first part of this question says, I want to find the slope of the line that is parallel. If the line is parallel, the slope is the same. So my parallel slope is the same as this slope, -3/2. If I want, then I want to find the slope that is perpendicular. If it's perpendicular, it's the negative reciprocal of the slope that is here. So my perpendicular slope is the negative, the reciprocal, and then I need to simplify. So my perpendicular slope is 2/3. My parallel slope is -3/2. Okay, number 10. Find the value of x and y that make line A parallel to line C. So, I need to find the value of x and y, x and y, which are right here, that's going to make A and C parallel. So I'm going to go ahead, this is what my goal is. I like to highlight so I know what my goal is. I'm trying to make them parallel. These two lines. That's my goal. So now, not looking at this piece in the middle, I can see that 62 and 7y plus 6 are alternate interior angles. So if they are, if 7y plus 6 equals 62, then those two lines would be parallel. So 62, because it's alternate interior angles converse, would say that would work. Because I'm making it parallel, it has to be the converse. So y being 8 would make A parallel to C. Now, if A is parallel to B, if I can prove that A is parallel to B and that B is parallel to C, then A would be parallel to C based on the transitive property of parallel lines. You said, but Ms. Singletary, if A is parallel to B, then A is parallel to C, we already know, then we know that they're parallel. You're correct, but we need, that's just the reasoning why. So, for A to be parallel to B, then, and sorry, this was A parallel to C, just so we know where I'm going here. So A being parallel to B would be the consecutive interior angles converse, because I'm proving parallelism, theorem, which means that if it's the consecutive interior angles, then that they have to equal 180 together. So 62 equals 5x, 62 plus, 62 plus 5x minus 2 would equal 180. When I find that value of x that makes that true, then I know that the lines are parallel. So, when x is 48, A is parallel to B. So therefore, I know that if A is parallel to C and A is parallel to C, I know that if A is parallel to C and A is parallel to B, I know that B is parallel to C by that transitive property. And if B is parallel to C, then I also know that A is parallel to C based on the same thing, the transitive property of parallel lines. So therefore, I found my values of x and y. Just proving, instead of just putting a bunch of numbers down and finding x and y, I'm just showing you how you prove it all interlocks and how it all comes together. So these two are parallel. Then I proved, these two were parallel, so then A had to be parallel to C as well. So both values work. Long story, same result. But it's important in geometry, it's all about reasoning and understanding why. All right, last but not least, our friend Mr. Proof, because we will have a proof on our test. always and forever, at least through first semester. All right, so we are given that G is parallel to H, which I see it's already marked. Angle 1 is 122 degrees. I'm just going to write it on my picture. And angle 4 is not on here, is 122 degrees. So I'm going to assume, what am I going to assume here? I'm not sure where angle 4 is on this picture, so let's think for a second and pause. Give me 1 second. Not quite sure where they want to place 4, because they left it off the picture. It's got to be somewhere it's congruent, so it would be congruent there. I'm just going to go ahead and make angle 4 here. Let's see if it works. We'll see if it works. That's not going to work there. We'll make it there. All right. Three can't be ever congruent to angle 4. This is a bad proof. We know that this piece is given. We know that 1's congruent to 3 because they are, 1 is not congruent to 3 because of anything. I think the angles are misplaced. I think 3 is supposed to be here. Bad, bad. Let's try that because it'll work, but it's not really what you want it. It's weird, but okay. Angle 1's congruent to angle 3 because they are now, because I renumbered everybody, corresponding angles. The postulate tells me that they are congruent because the lines are parallel. Then the measure of angle 3 is 122. Well, this again is a bad proof because somewhere up here I should have had the given that said the measure of angle 1 equals 122 degrees. So somewhere I needed to have this. Let's just correct this whole proof. So somewhere right here I needed to have that the measure of angle 1 was 122 because it was given. Now I can say that the measure of angle 3, I still can't say that yet because what am I going to have to do? Right, before I can even say that, I'm going to have to say now that the measure of angle 1 is equal to the measure of angle 3 by the definition of congruence. Now I'm just drawing an arrow. Now I can say that the measure of angle 3 is 122 by the transitive property. We're just going to correct this whole darn proof. The measure of angle 4 is 122 because that's actually given. I'm just drawing arrows to each line I'm doing here. The measure of angle 3 is congruent to the measure of angle 4. Well, before I get to there again, measure of angle 3 is not congruent. It's equal. So that's wrong. The measure of angle 3 is equal to the measure of angle 4 because they both equal 122. So again, it's the transitive property. And now that the measure of angle 3 and the measure of angle 4 are congruent, now I can say they're parallel by angle 3 and angle 4 by alternate exterior angles, converse, gotta have the converse, theorem. Well, I'm glad we corrected this whole proof. The one on your test, you won't have to. I'm just going to draw arrows since it's all kind of craziness. There we go. Well, I'm sorry about that being a really messed up proof, but we corrected it. We could handle it. We were good. The bottom line is when you're trying to do a proof that, one, you've got to have, when you're going from, again, equality to congruence, you got to have your definition of congruence. Again, when you're trying to prove that something's parallel, that's all my converses. Again, If they're already parallel, then it's just my regular old postulates and theorems. So we handled it. It was fine. It was good. We're smart. We can handle it. So thank you for taking that last wackadoo on number 11 with me. You all have a great time reviewing. Again, if you have any questions or any problems, please just see me before the test. Sorry this proof was so crazy. Thank you. Have a good night.